Hi, I'm here to give a presentation today on cheap and scalable serverless solutions with AWS. So if you don't know me, my name is Ben Hofferber. I go by HofNation on Twitter, and I attended the University of Idaho. I got a degree in computer science, and I really enjoyed my time up there. My sophomore year, I got recruited by Clearwater Analytics to be a software developer, and I've worked there for the last 4 years, kind of off and on. And when I started full time with a buddy in college, we ended up starting a startup called YoRally. And it was then that I started using the AWS ecosystem. And that's where I really started seeing advantages of being able to do all this kind of cloud computing software and being able to leverage AWS to really get a lot of value for pretty cheap. And that's what I'm going to kind of be giving my talk on today. So I'd like to describe development fraught with conflict. So this is kind of a big issue for me, and something that I can definitely see from a lot of junior developers. And what I'd like to do is kind of expose some of the perspective that junior developers have when they're trying to launch an application. So you've got a junior web developer, they have an idea of how to make an app, and they start with a simple web app prototype. They've done HTML, CSS, JavaScript, or they can learn it fairly easily. And that's enough to get you kind of started with a template or started with something very, very simple. It can take 3 hours, right, to get something up that you're ready to share. And sharing is really a big problem when you have something like this. When you have a simple web application, you could put it up on CodePen, you could put it up on JSBin, a lot of those sorts of services, but it'd be nice to be able to have your own thing. So that's what leads these software developers to go and start figuring out how to launch a server. And that can take about a day, and it costs about $5 a month, generally, to get just a simple server up that you can put whatever you want on, where you can install whatever you want. You can do Bluehost servers, you can do that sort of jazz, but to get something really simple that you don't have a long-term kind of contract for, it's about $5 a month. So this gets you the basics. Now, you start developing and you start figuring out that data is important. So this junior developer now has to learn how to use a database and set that up from scratch. And that takes another day. And why not put it on the same server? If you're a junior developer and you're thinking about how to make something new, you're going to try and put it onto like kind of whatever you already know. This person already knows what their server does. Why make another separate server? So it makes sense to put it on the same server. And if you're in this scenario now, talking to directly an IP address and directly a post or a specific port on that server doesn't appeal to most people. Most people like a .com. Most people like a secure.com. So buying a domain and setting up SSL, that's the next logical step for this developer to take. And this takes a while. If you've never done it, it just takes a bit, depending on like what you use. If you use like Bluehost or those sorts of things, there might be an automated process for that. You might be able to buy that straight out of the box, but a lot of times it takes a little while to get that set up. And depending on what kind of encryption you want, if you want the free Let's Encrypt, that's great. You can definitely get that. Or you can pay $3,000, $5,000, $1,000 for a industry grade SSL certificate. And you know that's definitely a big hurdle if you're really trying to get this .com up. So now this is basically kind of the base building blocks of getting something out there. At this point, you can scale pretty well. You scale very vertically. DigitalOcean allows you to very easily upgrade your box, upgrade your hardware, keeping most of the same settings, building that out. And so this will get you a long ways. And eventually, you get to the point where security becomes an issue. Enough people know about your website that some people are trying to inject stuff into your database, and it's time to learn how to secure your server. And as a developer, man, this is something I wish I didn't have to think about. I wish I really didn't have to worry about this. And this is something that basically no matter what solution you're using, even AWS, you're going to have to think about it in some respect. But it takes about a week to harden a lot of your systems. And that's a full week. That's a full 40 hours of going through a lot of code and trying to figure out where those vulnerabilities are, and that could be more. That's just what I'm thinking about right now. So next up, you need to start scaling. That's the next kind of step. As this project keeps evolving, you start thinking, okay, I need a load balancer. I need to figure out how that works with Nginx. I need to figure out how that works with Apache servers. And that just expands out. And that can take 3 weeks. It can take a long time to figure out how your specific application with the architecture you've created expands. If you've been doing things in memory on your server, you need to figure out how to not be doing that anymore and figure out how to distribute that process across multiple servers, and it starts costing a lot more money. Eventually, a lot of developers just break down and hire a contractor to figure out how to handle all of their server issues. A lot of small shops will do this because it's a lot easier than having that person on staff all the time, that qualified person on staff. So now I'm going to talk about how this is made easy by AWS. So getting a server, getting your code up on a server, S3 buckets solves the problem. You just upload the data and it's served up at an endpoint that's very shareable and very kind of consumer friendly. It's not perfect, it's not a .com, but this gets kind of the job done. Databases, boom, they offer databases that are scalable. You can have this database running out in the cloud. You don't need to own the server. You don't need to figure out how to make that database distributed. It's a lot of stuff done for you. Next up, domain and SSL. Boom, there's a service that handles that, Route 53. Put that behind CloudFront, and there you go. You've got your .com set up. That's serving up all your data in a very distributed way with CloudFront. And that handles your SSL certificate, which Amazon gives you for free with your account. Now, security, Trusted Advisor. That's their service for being able to recommend and analyze your account, be able to see what sort of security problems you have. Now, this doesn't solve everything, but this gets you a lot closer to being able to figure out what's happening with your server and that sort of thing. Now, when you start scaling, boom, it's automatic. That's really the big sell of AWS, is that it's very automatic to scale your software up. And when you think about having to need a contractor, I mean, it basically does your job for you. You don't need a contractor with this sort of thing. So now I'm going to talk a little bit about how AWS applications are architected. And this is from a kind of web app perspective. There's a lot of different types of applications. Today I'm going to be talking about web apps. And so specifically, I'm going to be going through this basic architecture that you can see here. So let's start breaking it down. First off, you've got S3, which stands for Simple Storage Service. And all this does is serve up static documents. That's basically all this does. It can be used to serve websites, files, videos, photos, all that stuff. And this gives you a very easy way to be able to post a website. And that's all it does. It's very, very straightforward file sharing system. You've also got Route 53 that does AWS's kind of domain handling for the most part. There's some DNS record management that it also does, but the big feature is that it hooks into a lot of these other systems so that you can use that domain to be able to publish your API to like a subdomain of that specific domain that you purchased. You can purchase domains on AWS, which is really, really handy, especially when you want to use those domains throughout all of what AWS provides. Next up is CloudFront. So this is basically a content delivery network from Amazon. And what that really gives you is it gives you global scalability so that you have a lot of different servers that know exactly how to manage the DNS connections happening that really need to be piped back into your server, but it gives you a lot more registration points for people to be able to access that specific data. And then on each of those access servers, it gives you caching and compression, which is really handy for being able to serve that data up really, really, really quickly to a lot of people that are potentially requesting similar data sets and similar web pages. So that's what CloudFront really gives you. Now, Lambda, unrelated to Half-Life in any sort of means. It's a video game made by Valve with a main character that carries a crowbar, if you're not familiar. And what Lambda really gives you is simple workers on demand. So you can write these workers and these little functions with Java, Python, Node.js. And what Lambda does is it gives you kind of an event-driven model where when an API request is made or an event is published in like the AWS system, that could be like in a messaging queue or from an endpoint, that event gets piped into Lambda. and then that runs a function which then outputs data, usually back into whatever kicked off that event. So in the case of an endpoint, that endpoint triggers a Lambda, that Lambda runs, and then it publishes a response that then that endpoint returns to the requester. So this gets really handy for being able to just spin up little kind of worker jobs on request. So you only really pay for the work that's actually done, rather than a server that's just sitting out there doing nothing. Then you've got DynamoDB, and this is Amazon's NoSQL database solution. It's hugely scalable, and they offer document and key value storing. For those of you that don't know what that is, basically it gives you a little bit of flexibility for how you store that NoSQL data, and it gives you a little bit better indexing into those data sets. And DynamoDB is really, really cool in that you basically have throttling on it, that you're kind of paying for as many requests as you think you'll need. And it's a little bit difficult to write for, but it's I think really a awesome NoSQL database solution if you can kind of bear with the syntax of it. Finally, there's the API gateway, and this is the way that you expose your API to the public. It provides a proxy, so it provides basically a web service layer that sits in front of all of your services and all of your Lambdas, which routes requests basically over to those services. And one of the awesome things is that this really protects you against DDoS attacks by allowing throttling on your basic API, just to make sure that you don't get crazy amounts of requests from the same user in a short burst, or a crazy amount of requests from all users in a short burst. So another good thing is that you get this kind of API presentation layer that gives you access to a lot of different services that could be very distinct and unique in a very kind of microservice approach, and it allows you to pipe those all into a simple endpoint. So this is what we're going to talk about today. I'm going to basically leave out the domain part of this. That's just a lot of configuration. It's not terribly difficult, and it's pretty well documented into how to hook that into CloudFront, how to hook that into API Gateway. That part's not terribly confusing. But what I'd really like to talk about is like getting a basic thing set up using these kind of S3 Lambdas with DynamoDB and an API Gateway. And so this is kind of a crash course on how to do basic architecture of systems. So this is what we're going to be making. It's going to be a simple web app called Crowd Chatter. There's a live example. You can go to this link right now and try it out. And so if you have any kind of questions about what's going on in the presentation, other people might be in this room and might be able to help you. I've also included in the top right corner, I'll have this link kind of hosted up there for the duration of this talk, and you'll be able to see kind of a little mini map of what the system that we're making is. So we'll kind of come back to that at the end of the presentation. So let's talk about creating the client. So I'm not gonna focus too much on the client because the client doesn't really represent the architecture of the rest of the system too dramatically. It basically is a simple React app that calls our API. So it's not too in depth. Simply, it's hosted on S3. So it's a simple. It eventually becomes a couple JavaScript files with a HTML file that references those files, and requests are made to the API gateway, which eventually call Lambda functions for us. So we have a simple GET request that'll get us all the messages down that we need, and we have a PUT request that will put a new message into that system for us. I created the client with the Create React App Starter, and that gives you kind of a boilerplate for React applications, which I've really enjoyed having. It really helps you get kind of started with React fast, and I would definitely recommend it for anyone really looking into getting started with React. All my HTTP requests use the request library, and there's not too many other libraries I'm using here. It's very straightforward as far as everything goes there. So let's start with uploading this to S3, because this is you've kind of created this basic client application, and now you need to upload it to S3. So simply, you just need to create a bucket, and that's as simple as specifying a bucket name, specifying the region that you post it in. The region kind of varies in as far as like how much it costs. I think Virginia has the cheapest rates at the moment, just simply because data centers in Virginia are a lot cheaper than they are in Oregon or Silicon Valley. So you've got some, I've got my bucket name here, which is just going to specify what that kind of directory is called. Okay, so the bucket configuration, you need to do a couple things to be able to get this to serve up kind of like a website. So first off, there's a static website hosting tab. And if you kind of do that drop down here, you can see that there is a button to enable web hosting. And all you need to specify is your index file to basically give you a simple file that you'll use to serve up basically the rest of your endpoints. And then after that, the only other thing you need to do is set up your permissioning. So you need to set up CORS for cross-origin configuration. And if you kind of open up this CORS configuration, it'll default you to this kind of basic CORS configuration. And that's what I like. I like using just that basic thing. Because I want anyone to be able to access this no matter where they're located. It doesn't matter to me where they're trying to request this from. The second step is editing the bucket policy. Because it's a website, we want all of these static files to be able to be published and for anyone to be able to download these files. That's not a concern here. We're not, as long as these files are minimized, you're not exposing any of your logic in a very clear way. You're not losing anything from allowing anyone to download these things. So that's what I do when I'm serving a website. And finally, you need to upload all your files. And I would just upload the directory that you're kind of outputted all of your minified code and just that public data. And in this kind of base folder, you'll need to have that index.html file. That's like the core thing that you definitely need to have in this folder. So for everything else, that's that S3 portion of this. That's done. We have that now. That's that kind of first step that I talked about with the junior developer. That's done. We're A-okay on that. We've got that part set up. That's published. Anyone can go to it and access it. So that's great. Now, time to try and use serverless for everything else. So serverless is this awesome framework that really helps you set up serverless APIs on Lambda with the AWS system. And what it does is it gives you database table creation, which is really nice. You can specify a bunch of different environments and be able to publish kind of all of your different services that you're going to rely on, like databases, like your API, like your permissions. You can deploy it to multiple tiers like development, production, staging, those sorts of different environments, and you have the ability to deploy your code live and to be able to like replace an existing API that's out there. So this isn't the only solution that does this. So there are other solutions, other frameworks that also do this. And I like serverless because I think it was the easiest for me to set up. I looked at some of the other ones and just the documentation didn't seem as clear, and serverless just seems like it has the fewest steps to get set up. So let's talk about setting it up. There's a little bit of configuration work that needs to happen with your AWS account, and I'm not going to really dive too deep into that. But once you've installed it and you're trying to run serverless, there will be kind of an initial get started section on the serverless website. And you can go there and figure out kind of what you need to do to set that up with your AWS account. But once you have that set up, it's very easy to create a boilerplate for Amazon AWS Node.js. And that's what I'm going to be going through today. They have a couple other options for you besides Node.js, but this is the template I'm using because I just want to use Node on the server side. So basically all you need to do, type in serverless, create, specify the template that you want. So I want Node.js, and then specify the path, and that path is going to say what service you care about. So in this case, I'm doing example, but for the end case, I ended up doing messaging because I'm going to make basically a messaging API that's going to have a get and a put, like I talked about earlier. But this basically specifies kind of what path it is to that service and generates that for you. And then, as you can see, it generates two files, a handler and a serverless YAML file. So then for setting up this project, there in that YAML file, you can go in and start specifying different kind of bits. And for the first two bits, we're going to specify what the service is called. In my case, it's going to be messaging. The provider is going to be AWS. We're going to be running on the Node.js 4.3. That's the latest that's provided by AWS currently. And we're going to be deploying it to development. That's just going to be the tier that I'm going to be defaulting to, and a US West 2 region, which is Oregon. Just because it's close. That's the one I like. So then we get into functions, and this specifies your Lambda functions that you want to deploy. So I have a get messages and a create messages. Both of these direct to that handler file, and that handler file will export two functions. One's a get messages function, and the other one's a create message function, which we'll talk about writing later. And these process events, and the event that I really care about because I'm generating an API is HTTP requests. And so by specifying HTTP, this will specify to kind of serverless that they want to set up a API gateway endpoint with a path message and a method get and a method put. And you can see that those are respective to get messages as a get, create messages as a put. And then both of those I want to allow CORS cross-origin requests, not a problem because this is a public API. And then for my resources, I have a DynamoDB table that I care about. So I want to create that and make sure that that's created for me. And I'm going to name that table chats because it's a chat messaging app. So we're going to name it that. And for the attributes, I'm going to specify that there's a presentation. And you can see that there's a definition and a key schema. So you have to define your attribute definitions to specify kind of your key. And you have to specify kind of what types those are above. And then below, you specify kind of what types those keys are. So I think you always have to have a hash. That hash is really important if you ever want to query your data. If you're okay scanning your entire table every time, I don't think you need to specify this hash. But it's, in my opinion, it's pretty important. And so I'm specifying that as presentation because I want to be able to query it really easily later. And then that's a string, and it's going to be hashed because it's a string. I'm also specifying a timestamp number, which is going to be just a UTC millisecond timestamp. And then that attribute name is going to be timestamp, and it's going to be a range type because it's going to specify, since it's a number, it can specify different ranges of data within the database. So if I want to pull like just a single day, I can specify two ends to that range and be able to very efficiently pull down a single range of data. The final bit of this is that there is a provisioned throughput section. And this specifies basically how much read and write capacity you're going to make available for your DynamoDB database. And then the second bit after this, once you've kind of specified that table, is you need to specify that your Lambda functions can actually access that table and how they're going to access that table. So here we specify a new policy name, Lambda DynamoDB, and I think this is an existing policy that already exists in AWS. And the version is available there. I kind of pulled this down from an existing example, but specifically I want to be able to query, and I want to be able to put a single item in. And so those are the actions that you see there. And I want to allow that on the table chats specifically, because that's what I'm actually using in my endpoints. No need to specify all tables. I just specifically want the chats table. And then I specify the role configuration as well. So that's basically what you need to do to be able to set up the basic configuration for the API we need to make. The second part is now creating the handler for the put request that we're going to do. So over on the left side, you can see that there's some headers and some imports that I'm going to use. So I'm using Ramda's merge, and all I'm doing for that is I'm saying, hey, here's a template that I want, and whenever I'm returning a response, I just kind of want to use this template to be able to specify a couple things, and then I'm just going to tack on any changes that I need from that template. So for instance, if you look at the top of the handler, when we go to create a message, if we're missing some query strings that we expect, like an author of the message and like maybe a message body, we're going to actually return a 400. You can see that that response object has a status code that's going to actually overwrite that template status code there. And then it's actually going to specify a new body. And so when we merge that, it's going to overwrite the existing parameters of that response template and then put in any new parameters that it needs. So basically, we're going to return that callback like that. So this callback takes in a error and a merge, and a response template. And that error will actually not return any of this information to the user of your API. That'll actually error out the run in a very much system failure type way, and it'll just return a generic 500 message to the user, which isn't very helpful. So I like being able to return an actual message and an actual error code to my users of my API. So that's why I'm specifying it the way I am. Next up, we've got a DAO. I'm going to show that next. But basically, we're just going to pass in a little bit of information. I'm passing in that my presentation is this serverless talk that I'm giving. And authors are going to come from the query string. Messages are going to come from the query string. And my timestamp of my new message is going to be just the UTC date time that you can get from the JavaScript data object. Now, that DAO method is a promise. So when that returns and it returns success, we're going to actually just return a message that said that that successfully was submitted, that message that was passed in was successfully submitted, and we're going to return that happened. If there was an error, we're going to return a 500 instead of the 200 that's defaulted in the template. And we're going to give a little bit of information to the user, say, hey, the server had an error with this. We don't have a more granular information, but this is what we have. So that is it. That is all you need to do for the handler. Now, for the DAO, this is actually what's going to query the AWS DynamoDB database. So first, we're going to pull in the SDK. And then we're going to use the SDK's document client. And this is the client that I really like to use. I find it a lot more straightforward than some of the other clients that are available, but this isn't the only option. We're also going to pull in a Lambda function that I'll use in the next example. So for the query logic for this, we're going to insert a new message. And so this is that, just defining that promise. We're going to insert that. So the document client's put function takes a parameter object. And that object specifies what table you're inserting that put object into. And for the item, specifying what document you're putting into that database. So that's what you're specifying there. If it throws an error, let's reject. If it doesn't throw an error, throw a resolve. That's very straightforward. Next up, let's talk about the get endpoint. So for the imports, I'm just specifying the same imports that I did a couple slides ago. If you look back here, those imports and templates are the same as the new one, the ones that show up here. So we're just using that same template that we already had. And if we're getting messages, we don't need to specify, make sure that the get requests query strings were correct or anything like that, because you're just getting all the messages. You don't need to pass anything in. So we don't need to check that. We're just going to simply call the DAO, get those items back, and pipe those into the body. So if there are any items that we returned, we're just going to pipe those into the bodies, messages item, and just pipe those items right in, and then return that. If there was an error, we're going to do the same thing that we did in the other endpoint and just return a 500. So the query logic for this is a little bit more interesting. I'm specifying the same imports that I did a couple slides back. If you look at the imports here, I'm just importing the same stuff. This time I'm actually going to use that lambda emit function that I didn't use last time. And what we're going to do is we're going to return a promise. And these parameters are a lot more interesting because we're doing a query. I had to use a query and not a scan. I could have used a scan, but what I really wanted to do is return the top 200. And when you do a scan of a DynamoDB database, you do not have a guarantee of the order. So even if I scan in index reverse order, there's no guarantee that I'm actually going to get the most recent messages. I might get a mix of a bunch of kind of differently placed messages. There's no real guarantee there. So I had to use a query, and that made this query that I'm making a lot more complicated. So let's try and walk through it here. So first off, I'm talking about the chats table. I'm going to scan the index. I'm not going to scan the index forward, so that's set to false. And basically what that means is that range that I have, that timestamp range, that basically says if I was going to scan that index forward, that would say I'm going to do that in ascending order. But I want to do it in descending order because I want the most recent message. So I want to get the most recent message and all messages that came before it. So I want to flip that index. I want to limit it to 200 messages. And then when I specify this key condition expression, I need to specify a bunch of different kind of variables. And those variables can go into these expression attribute names and expression attribute values. The names part specifies what of the existing database am I looking at, like what columns do I need to look at. And the expression attribute values specify what values do I want to compare those existing attribute names to. So in this key condition expression, I'm making sure that the presentation equals the presentation that I passed in as an attribute value, serverless talk, and that the time, or the timestamp, is greater than 0. So greater than 1971.1, I think is epoch time. So, and then I'm just going to pass this into a query. And when I resolve, I'm going to actually omit presentation, because since both of these endpoints are just returning from this single presentation, that's just an implementation detail I had to make this query work. Previously, I had that be the author, but you actually have to specify a value for that key if you want to query from the database. That's just a DynamoDB thing that you have to do to be able to get this to work. And that was really frustrating for me. I still like DynamoDB though, for some reason, even though it's being a jerk to me sometimes. So it's just really simple, and it's a lot of fun to use. So that was just some quirks that I had with this. So that's all the code that we needed to do. It's pretty simple, pretty straightforward to be able to get some of that stuff done. There's some little nuances there, but it's not too bad. So now when you go to deploy with serverless, you just serverless deploy, and this will deploy to that environment that I configured earlier. So if we go back, we specified here that I'm deploying to the dev stage in the region US West 2. So you can kind of see what it does. It packages up the service, throws a CloudFormation file, and what CloudFormation is, if we go forward here, you can see CloudFormation basically specifies, hey, I'm gonna deploy this like set of things, and it's kind of like your cloud management solution that AWS provides, and it specifies like what API gateway functions are you deploying, what Lambda functions are you going to need to deploy, and this kind of builds your little stack that you'll need to deploy all those things. So that gets uploaded, and then second, you also have a zip file that gets sent to the S3 with all of your Lambda stuff in it, and that gets uploaded, and then from that zip file you update the stack. And then if you were doing this, you would probably be creating your stack for the first time, but in this case I was only being able to capture me updating an existing stack, so it'll look a little bit differently. And if there's problems, you can go and look at this same CloudFormation file to be able to see some errors that happen. You can see I had an issue rolling back at one point, so it gives you a little bit of debugability. So once that update gets finished, it'll give you information about the service that it deployed. So it deployed the messaging service to stage dev in the region US West 2. I didn't specify any API keys because it's a public free API. I don't care. I'm just trying to get it off the ground. And I made a get and a put endpoint. They're both on the message path of my dev tier. And you can see that it specified me a nice URL from Amazon. And then I created 2 functions, and you can see the function names and IDs there below. So that's it. That's all you need to do to be able to get something kind of off the ground. It's not a lot of code to be able to get a simple backend set up and to be able to architect these things. And I really like how I was able to leverage serverless, the serverless framework, to be able to get me kind of a lot of this for free. And you can test and deploy to other tiers, and that's the really nice thing, is you don't need to set up a bunch of different environments for you to test in. You can basically spin those up pretty dynamically using serverless, simply with a tier parameter when you're deploying that gives you the option to deploy to different tiers and to be able to deploy different APIs to different tiers and that sort of thing. So I've really found it to be a pretty amazing process for me going forward. So that's what it took to make my app. So personal benefits that I've seen. So for starters, it's so much easier for me to deploy cool websites and cool web apps that I think are fun. If I want to really mess around with like creating a Lambda function that helps me make an Alexa app, it's very easy for me to do this with the tooling that I've shown today. It's really easy for me to create a simple little React app that does a cool tool. I created a JSON diff tool that a lot of my colleagues at work use, and that was something that I just deployed to S3 and was able to share with them within a day. And I got feedback and was able to redeploy it that night, and it's just been a really amazing process for me to be able to make things. Second, I think it does promote better coding practices. I think it's really awesome to be able to say, hey, this is a distinct microservice that does a very distinct subset of tasks. And as long as you're not throwing every single endpoint into the same service, I think it really promotes you thinking about, oh, what is my specific service of my API need, rather than thinking about your services like this kind of monolith structure. I think it really breaks some things down. It really makes you kind of separate your concerns. Second thing, the third thing is I don't have to think about scalability. That's always a problem. It's always a big issue when I have to think about, okay, well, how does this scale, right? That's something that you always hear people talk about. People like Google always talks about, speed and scalability, and it's just not something I have to worry about when I've got something like this set up. If people start using it and I need to scale, it'll kind of hold my hand along the way here. And the final thing is cost. It is so much cheaper. You can see in the month of February, I was running a EC2 instance, and that was costing me about $20 a month. And I went from that to running a Lambda instance, and you can see that my estimate is $10 less. That whole server I just shut down, and I'm basically not paying any more money. Now, not a lot of people using my application. If I was using if I had an application that was an existing application that was visited by millions of users a day, this would maybe be a different story. But for me, kind of just trying to get a side project off the ground, this has been great. It's been awesome to be able to do this. So that's kind of my talk as far as how I've architected systems. I'd be really interested to answer any questions that anyone has about how to architect their own systems, any problems that you've kind of run into with using AWS. I'm going to go through and answer a lot of the questions that people have been having in the chat room. All right, well, thank you. Bye.